Welcome back, everyone, to the 33rd conference for WALPA. And we're starting the session 7. It's on waves and source tracking. We have 4 presenters this session. The first is Basile Cousin, and he'll be talking about literature review of sediment and nutrient resuspension. Thanks, Basile.
From France, from the University Lyon 2 and Lyon 1. This presentation is co-written by Eva Crawford, Krystal Saunoa, and Frank Wilhelm from the University of Idaho, from Department of Fish and Wildlife Science in the College of Natural Resources. This presentation will talk about the phenomenon of sediment and nutrient resuspension in response to hydrodynamic disturbance originated from the surface. So, in the first time, we will define the study objective and the method that we use to review the literature. In the second time, we will present some bibliometric about the worldwide distribution of the research on the resuspension phenomenon and the aspects that are covered by the literature. In a third time, we will explain the main ideas from the literature about the resuspension phenomenon and the main result from the meta-analysis that we made. Then we want to discuss this result and extracted the main challenges of the research in future studies, and also make some recommendation and suggest future direction for research. This literature review that we made focused on the resuspension phenomenon induced by surface hydrodynamic disturbance, both from natural origin, mainly wind, and from anthropogenic origin, mainly boats. We peer-reviewed more than 180 articles on the phenomenon of resuspension, from which we extracted the main ideas. On this article set, we extracted the data of 33 of them that we implemented in a metadatabase that allow us to make statistics at a worldwide scale. So, what are the results? First, about bibliometrics, we can see on this plot the distribution over time of the number of publications on the resuspension phenomenon. So we can see that there is a clear increase of the number of publications since 5 decades, and especially since 2001, with many new publications every year, and this dynamics seems to continue with 7 new publications since the beginning of this year. This figure represents the geographical repartition of the studies on the phenomenon of resuspension. We can see that North America represents a great part of the studies on the resuspension phenomenon, with 25 articles published on the phenomenon. China also represents a great part of the phenomenon resuspension studies, with more than 40 articles published. In a lesser extent, also Europe and Oceania, mainly with Australia and New Zealand, has published on resuspension phenomenon. This figure represents the typology of the studies that we implemented in the metadatabase. We can see that most of these studies are field studies, with 25 studies. 8 studies are laboratory studies, and 2 studies are modeling studies. A large majority of these studies focused on wind-induced hydrodynamic disturbance, with more than 26 studies, compared to only 5 that focused on hydrodynamic disturbance in general, and only 3 on boats, and 1 more specifically on boat. We can also identify that studies focusing on boat are only field studies, while studies focusing on hydrodynamic disturbance in general are only laboratory studies. In contrast, studies focusing on wind were studies of all types. This figure represents the parameters that were used to characterize the hydrodynamic disturbance And this figure represents the parameter that was used to characterize the effect of this hydrodynamic disturbance. Both of these plots are for the metadatabase article that we implemented in the metadatabase. What we see is that most studies used wind speed to quantify the disturbance and focused on suspended sediment parameters to measure the effect of the hydrodynamic disturbance. When the studies also focused on nutrients, they mainly reported to the total phosphorus with more than 15 studies, then total nitrogen with 9 studies, but rarely on dissolved nutrients. Only 7 focused on dissolved phosphorus and 5 on dissolved nitrogen. To quantify the disturbance, shear stress was reported in only 6 studies. Also, what's something interesting to mention is that on 4 studies on both, 5 different parameters quantifying the disturbance were used. Now we want to present what are the main ideas from the literature on the resuspension phenomenon. If we add sufficiently strong winds on both at the surface of the lake, hydrodynamic disturbance will occur in the water column. First, in the surface by an increase of the wave height that will increase as a function of the wind speed and the wind fetch for the wind hydrodynamic disturbance, and as a function of boat type, distance of the boat passage, and boat speed for the boat. The wind and the boat will also act deeper down in the water column by increasing the current speed. With this increasing of the wave height, it is associated orbital movement that originated from the surface and are directed towards the bottom. This combination of orbital movement and current speed will create shear stress on the bottom. This amount of shear stress in the bottom is dependent on the depth of the water column as conditioning the transmission of the hydrodynamic disturbance towards the bottom, and also the intensity of the hydrodynamic disturbance. Once a critical value of shear stress is exceeded, sediment will start to be put in suspension from the bottom to the water column. This critical value of shear stress is dependent on different parameters. First, the granularity of the substrate, but also its cohesiveness, and also if it is organic or inorganic material. So it will be more shallow zone with thin sediment that will be more prone to resuspension. This plot from the meta-analysis that we made show to us the clear increase of suspended sediment concentration in the water column after a resuspension episode compared to before. The literature also interests itself to the nutrient that can be carried with the resuspension episode. They mainly concentrated on phosphorus and nitrogen, both in particulate and dissolved form. It has been shown that the dissolved nutrient not always increase after a resuspension due to the high numbers of parameters that control the liberation of nutrient from particulate to dissolved form, such as the pH value, but also the amount of iron in the sediment, and also the quantity of oxygen in the water column at this moment. The nitrogen also has been shown to not always increase after a resuspension episode, and we attribute this non-always increase to the literature that focus mainly on already eutrophic lake, so with a high value of total nitrogen in the water column even before the resuspension occurs. However, all the literature is in accordance to say that the total phosphorus increase almost always after a resuspension episode. We attributed this increase of total phosphorus in the water column due to the high concentration of phosphorus in the bottom sediment, and when these bottom sediment are put in suspension in the water column, they carry with them a high quantity of phosphorus. And this result is supported by this linear regression from the meta-analysis that we made, with a strong positive relationship between total phosphorus and suspended sediment in the water column. Then the literature to quantify the increase of algae in response to hydrodynamic disturbance made the measurement of chlorophyll A, but we detected a big biases of the literature in this measurement because recently deposited material can be detected as development of algae, but are result from a resuspension of vegetative material. However, when this resuspension is detected after a more long period of time after the resuspension episode, it can be due to the development of algae. These biases can explain the high variability of response of increase in chlorophyll A after or during the resuspension episode compared to before. Then the literature has shown that the resuspension can be a trigger for eutrophication. First, by increasing the phosphorus in the water column, that has been shown to be the limiting nutrient in aquatic ecosystem, and also continued turbid condition may favor floating species compared to rooted species. These processes can lead to the depth of biota and great concern for human health. However, there is a different trend when there are macrophytes in the water column. First, emergent macrophytes, they can act on breaking the wave, but also breaking orbital movement and currents in the water column, but also by pumping the nutrient in the sediment and maintaining the surface bed. The literature also shown that submerged macrophytes act kind in the same way as emergent macrophyte, and also floating species plays a role, but more by pumping the nutrient already released in the water column. So the macrophyte act on hydrodynamics by breaking the wave, breaking the orbital movement and current speed, on sediment by maintaining them, and on nutrients by pumping them both in the overlying water and in the sediment. So the macrophyte act on all the aspects of the resuspension. Now we want to discuss this result and mention the main challenges for future research. First, we detected a unequal distribution of research worldwide. This high concentration of studies in North America can be attributed to the high productive traditional research in limnology. In Asia, a high concentration of studies are led on like Taiyu in China with more than 44 studies on resuspension phenomenon. It can be due to the high numbers of algae bloom that can occur on the lake and the fact that it supplies drinking water for more than 2 million people. We also detected that the research focused on already eutrophic lake, so this doesn't allow us to know the consequences of resuspension in oligotrophic lakes. Also, we detected a lack of studies on hydrodynamic disturbance from both, with studies that focus mainly on wind-originated hydrodynamic disturbance. Also, we detected too much heterogeneity in the way of characterizing the disturbance, and this really prevent comparison between different studies and also the establishment of clear management policies, and this also prevent the identification of resuspension phenomenon. Also, we detected a lack of studies characterizing spatially the phenomenon in lakes. Also, the studies focus mainly on short-term scale effect, and we don't know the effect of hydrodynamic disturbance at the scale of week or month, for example. And also, there is a lack of interrogation on the interaction and comparison between external loading and internal loading, and how the external loading can play a role in the internal loading, and what are the delay between high external loading on the extent of the internal loading, for example. Then we want to make some recommendations for future research and for lake managers. We think that interdisciplinary team of researchers will be very efficient and very interesting, specifically with ecologists, geomorphologists, and physicists in fluid mechanics. Also, the use of ADV and ADCP technology will be very interesting because it has the capacity of measure hydrodynamic disturbance in the same time as suspended particulate matter. Also, there will be a need for manager to monitor trophic status of lake before and after the resuspension episode. Also, substrate composition and bathymetry are essential parameters to take into account in the resuspension phenomenon. Also, in the case of nautical practice, according to these two parameters previously mentioned, there will be a need to establish no wake zone. And also, there is a big need to encourage lakefront property owners to have a uneven and macrophyte covered shoreline to avoid reflecting wave and multiplying the resuspension effect. Thank you very much for your attention, and now I am available to answer to all your questions and comments. Thank you.
I thank you very much for your almost doing it twice for your talk on your literature review, Basile, aka Le Boss, I hear. And I hadn't really thought about this, but I think you should get in touch with the model for King County. Maybe we can add this to make Tim's job even more exciting. Thank you.
Thank you.
Mm-hmm. So our next speaker is Heather Crawford of the University of Idaho. She'll be talking about using ground-based Lidar to measure shoreline accretion. Thank you, Heather.
Okay. All right, so hi everyone, good afternoon. Thanks so much for being here. I'm Heather Crawford, and I'm gonna cover the basics of using ground-based LiDAR 3D scanning to measure shoreline accretion and erosion in response to waves and wakes. I'm a first-year master's student at the University of Idaho. I'm working with Dr. Frank Wilhelm, and for this presentation and for most of my thesis, I have also worked with Dr. Jan Eitel from the University of Idaho, Basile, who presented just before me, and of course with Frank. And I'm not sure if this is moving ahead of me or not, so I'll just keep going. So to give you guys a quick overview of what I'll be talking about today, I'm just gonna provide you with some of the background and the big picture of my thesis and my research, the entire thing, and then talk about how we go on to measure anthropogenic and natural effects on the shoreline. I'll introduce you to terrestrial laser scanning, or TLS, which is the methodology that I'll be talking about today. So the basics, the utility, kind of the analysis behind that. I'll talk about going about quantifying shoreline changes in the shoreline, both with accretion and erosion. I'll talk about the pros, cons, costs of this method, and then I'll kind of summarize everything up and talk about what we're going to work on moving into the future. So next. Okay, so the big picture of my research comes down to mainly four things. So if you click 4 times, they'll come up. So it comes down to waves, wakes, sediment, and nutrients. So overall, I'm looking to determine the amount of material resuspended from wave versus wake disturbance, and then the subsequent amount of nutrients released into the nearshore environment from those disturbances. So basically, how is water quality affected? And you can click one more time. Okay. So just to clarify, we define waves as naturally occurring, so pretty much from wind mainly, and then wakes are anything anthropogenic, so basically from boats, they're human generated, and we particularly concentrate on large boats and boats that create larger wakes. And so one of the end goals of my thesis is to be able to separate the anthropogenic wave disturbance from natural wave disturbance, and to determine the effect boat wakes have on the nearshore environment so that we can understand and quantify those effects. And by separating anthropogenic disturbance from natural disturbance, we can provide information to data managers and policymakers that they can use to make science-driven decisions that maintain all interests. So it's important to maintain water quality. You can click twice. Obviously, we all have an interest in maintaining water quality. That's why we're here. But there's also an importance to maintaining recreation. So we know it's hard to tell people what to do and what not to do. But recreation is also really economically important and should be considered. And so balancing the two is crucial for maintaining both. You can go next. I have to do a couple clicks. one more and two more. Okay. Okay, thank you. So the system that I am working on is Payette Lake in Idaho, also known as Big Payette Lake. It's a glacially formed, pretty large, deep oligotrophic lake in west central Idaho. Right on its south shore sits the town of McCall, Idaho. Oh, there we go. You can keep going, I'll just keep talking. So I don't know if any of you are familiar with McCall, Idaho. It's about 5 hours south of Spokane and 2 hours north of Boise. And it's the town that sits on the shores of Payette Lake. Payette Lake serves as the drinking water source for the town of McCall and for others who live around the lake. And it's also one of the main economic drivers of the region through tourism and recreation of all kinds. So on the lake, this includes, as we all know, swimming, kayaking, fishing, motorboating, jet skiing, things like that. And while we know and have studied the effects of wind and natural wave phenomena on this lake, you can click one more time, I think. Understanding the effects that recreation has on the physical and chemical properties of the lake grows more important as recreation becomes more prominent in these regions. And on to the next slide. Thank you. So we focused really on the question of how recreation, specifically motorized recreation like boats and jet skis, affects the lake shoreline outside and on top of how wind waves do. So understanding these effects becomes increasingly important with advances in boating technologies, especially those that enhance and maximize wake height. And since boats like this are relatively new, their effects on lakes, erosion, and water quality hasn't been widely studied yet, so that is something that we aim to do. And then I don't know if any of you guys have noticed, but these things are also getting really popular and really fast, at least around here, so that's something else to consider. And then we also need to consider kind of our regulations in place on the water bodies, so speed limits and no wake zones, as well as the characteristic of the lake and the shoreline. So how deep is the lake? What kind of substrate do you have in the near shore environment and on the shoreline? And is the shoreline developed or not? And so it's really important to figure out how recreation, all of these things considered, affects the shoreline and in what way. And we can ask not just how boats affect the shoreline, but then how do we quantify that effect? And does disturbance from human activities result in erosion or accretion? And then if we go on to answer those questions, we can say, how do we accurately quantify the amount of material being released from those activities? And from there, can we attribute nutrient concentrations to the material being released to quantify the concentration of nutrients being released through each kind of disturbance or activity? Next. So to get there, to answer that question, which is a pretty complicated question, part of the way that we get there is we're using what's called terrestrial laser scanning, which is a form of ground-based LiDAR three-dimensional scanning and rendering. And what the heck does all that mean? Some of you may have heard of this, but if you have not, because I definitely had not heard of this before I started this project, this is what the basic setup looks like. There's a photo on the right-hand side of your screen. The scanner I use is a Leica Geosystems, that's the brand, ScanStation C10 3D laser scanner. So it's this gray and green box thing on top of the tripod. And it weighs about 13 kilograms, 30 pounds just by itself. Its carrying case weighs a little bit more. So it's super fun to carry around all the time. But it does really cool things. And so you can see that it has like a little screen on the bottom, I guess bottom left in this photo for operating it. And then in the green part in the middle where there's a gap, that's kind of where all the work really happens. So the scanner sends out a green laser, which in the smaller, closer up photo, you can see a little green dot. That's the green laser that it sends out. And then the black box in the middle contains mirrors. And so while you're scanning, it rotates to reflect and send out that laser beam. So it spins around. If you click, there is a video that I think you can play, hopefully. And it kind of shows you what that does. So that black box spins around and basically the whole time the laser is being projected and reflected back. And then the scanner also rotates on its base on the tripod, so it can complete up to a full 360-degree rotation within the time period that you're scanning. And then you can scan at various resolutions. You can scan at low, medium, high, or very high resolutions, and all take different amounts of time. So a low resolution scan takes only about 3 minutes, while a very high resolution scan takes about 90. And so for my project, I've been using high resolution. It takes about 45 minutes to complete a full 360-degree panoramic scan. And then the scanner also comes equipped with a camera, so you can take a photo of the area you're scanning to reference back to if that would be useful for you. So you can go next. Okay, so how exactly does this work once you get this thing? And how does it provide usable data? So to set it up in the field, the scanner sends out this green laser. If you click twice, probably, it sends out this green laser, and it measures the time that it takes the laser to reach and reflect back off of an object. And then that correlates to the distance of the object from the scanner. So it does this like millions of times within a single scan. This thing moves crazy fast. It can send up to, it can scan up to 50,000 points per second, which is pretty impressive. And then what it does with those millions of distance readings is it makes data points for each time the laser hits something and bounces back. So there's millions of data points. And it puts those together into what's called a point cloud, which is basically just a digital rendering of the scanned area. And what you see on the bottom is what it looks like on the screen of the scanner when you're done. And then with the green laser, actually, and this is pretty cool for this application, is that it can actually scan through water too, up to about 2 meters of water. And that depends really on the lighting and the refraction and the movement of the water and the turbidity and quite a few other factors that can mess with the accuracy of registering underwater objects. So it's possible, but be a little cautious with it. This black and white photo here is kind of generally what it looks like if you scan underwater. And you can still see a pipe sticking out, but it might not be as clear as something that was scanned out of the water. So next. Okay, so then to actually take the scans once you've done that and to play around with and analyze them, you take the point cloud that the scanner outputs and load that into this Leica Cyclone software computer program. Cyclone is the point cloud processing software that Leica Geosystems developed to complement their scanners. The deal with this is that unfortunately the scanner outputs files that can only be read by the Cyclone software. But of course the software doesn't usually come with the scanner. So they make you purchase a license separately, which is wonderful. It's kind of an expensive program and you don't really need to perform a whole lot of actions within it. You can do more if you want, but it is really necessary if you're going to do anything with your scans, because this converts them to a readable, like a file that's readable by other programs, other than a file that is only readable by this Cyclone software. So basically you import your scan files and then you convert and export them into a readable file. And then these readable files can be imported by a variety of programs. And I have been using Cloud Compare, which is an open source software project designed just for this, for 3D point cloud processing and analysis. And there are a variety of tools you can use within this software, depending on what you want to look at in your scans and what your application is. But what it does allow you to do, and what I've been doing, is you can import multiple point clouds, so multiple scans of the same area, and you can line them up. Even if you didn't scan them exactly from the same location, you can still line them up and overlap them, basically one on top of the other. And then you can use tools to compute the distance between the points of those different layers. And so that kind of quantifies the amount of change the shoreline has experienced in the time between scans. And you can only do this in one dimension at a time, so you can only do the X, Y, or Z dimension at one time. So with erosion or accretion, in my case, we're mainly concerned with changes in the Z dimension. But that is basically what this program allows you to do, and that's kind of how you go about getting something useful out of these scans. So if you go next. So this is what you get from all of this. If you click, there's a photo of one of the scans that I've analyzed. And so this shows you the change in the Z dimension for one of our sites for the month of July this summer. And I really only recently, like last week, learned how to access the software and be trained how to use it. So this is the only site that we have had time to really get results for in time for this presentation. There will be more coming soon. And so I use the M3C2 tool, which you can see on the top of that colorful bar. That's the name of it. And so that is what computes the distance between points of the two clouds that are overlaid on top of each other. And then the bar on the right tells you what vertical distance each color correlates to. And the units are in meters. So as you can see here, it doesn't look right now like there's much vertical change. The only thing that's hard about that is, I mean, the green color goes down to about like 1.5 meters of change. And so it doesn't show me right now very precise unless I zoomed in, but I wanted to show you guys what this looks like. You can also export this file though and put it into a program like R and make a map out of it that allows you to really kind of get into the nitty gritty And you can actually get up to sub-centimeter accuracy of change in these scans, which is, I think, a really cool thing. So you can really accurately quantify how your material is moving. And like I said before, you can only do this in the X, Y, or Z dimension. If you wanted to get multidimensional change to understand all the movement of sediment on your shoreline, you can do one in the Z dimension and one in the X dimension or something, and kind of overlay those on top of each other afterwards and see how you have multidimensional change. You can see some red up in this image. That was just a kayak rack that the homeowner had. And so you can kind of see how things will really show up if they're moved a lot. So you can go to the next slide. Thank you. So really, to wrap that all up just really quick, the basic process is you go out and you scan. The scanner produces a point cloud. You convert that into a usable digital file, and then you use a software program of your choosing, and you analyze that file, and that allows you to quantify that dimensional change, whatever dimension you want. So basically to quantify erosion or accretion, and it does this really precisely. You can go on. Thank you. Thank you. Okay, so once we get to quantifying those changes in the shoreline, this may seem a little bit basic, but it's definitely something to consider. We have to think about the fact that the material resuspended has moved and it has to go somewhere. And so when the wind picks up or a boat comes by, and we see that effect reach the shoreline, the sediment's released and we see turbidity. And then once that sediment is released, it's most likely going to move somewhere if it doesn't just settle back down. So it's either in the process of erosion, where it moves away from the shoreline and can be deposited further away and building up the lake bed further away from shore. But what if that is not the case? So what if you go to the next slide, so what if instead, when the sediment's released on the shoreline, it moves in a different direction? So it could be pushed up further on the shoreline and be accreted, actually, rather than eroded away. And I know, like I said, this may seem obvious and basic, but I had honestly never really thought about accretion and erosion, or accretion as much as erosion. Because all the focus is normally on erosion. That's all you really hear about. But it is really important to consider the entire movement of materials within the lake. So, everything, it does have to go somewhere, and it becomes apparent that there is this incredible movement of sediment, not just within the lake that I'm studying, but within probably most lakes. And some part of the shoreline may be gaining material while other parts are losing it. And the cool thing about this laser scanning technology that I'm using is that we can not only measure erosion, but we can also measure accretion and do that really accurately. And then, tying that into the bigger part of my thesis. So not only does that affect, shoreline composition and physical nearshore dynamics, but while this material is released and moving, it's moving. And while it's moving, it could be releasing nutrients that contribute to eutrophication. So next, please. So like I said before, all I had really thought or heard much about before was erosion. And when I started this study, and I still get a lot of citizen calls and complaints from property owners around the lake, and they pretty much all had to do with erosion. People really don't like losing their beach or losing square footage off of their property. And so one example shown to me was this set of stairs off the dock. It was built about 20 years ago, according to the homeowner. And as you can see, the steps now just hang in midair. They're about 2 feet off of the ground. And that's a massive amount of erosion within those 20 years or so. When they were built, obviously the steps went down to the beach. And then others complained about pipes and rocks sticking out that I have never shown before. Some folks called me to look at this, which is their patio had collapsed from big wakes repeatedly crashing into it over this summer. And then they said a significant amount of their beach had also eroded. And so this is what people are concerned about. This is what is usually more noticeable or negatively affects them. And it's really what they want to reach out about, and really all I'd heard about or considered before. But we finally heard of another Pale Lake, which was interesting, on the next slide. So this gentleman contacted Dr. Wilhelm and I about something that he had observed on his property. If you can go to the next slide, and probably 2 clicks. Okay, so if you look at this photo, it's kind of just a portion of a photo that was hanging on the wall in this guy's cabin. It was taken in 1987. If you can, and if you could click, please, if you just take a second to look at this rock that's circled in red. It's the biggest boulder sticking out on the shoreline. Fast forward to 20 to 30 something years later when we get this call. And so I went down to check it out, and then this is a photo of that beach now. And so it's the same house, same photo angle. You can't see the boulder. You can't see any of those rocks, but you definitely can't see the boulder. It's actually right there. If you click, there's a circle around it. And it barely sticks out anymore. You can probably click a couple times. There's a close-up. So this guy had marked it when he noticed that it started to be surrounded by sand, that the shoreline was accreting in that area. And he says that this like really just happened within the past 10 or 15 years. But we know at least from the time of that photo, so like 33 years ago, it's happened at least then. And that is also significant accretion. And that's not very far down from the erosion where those steps were 2 feet off the ground. And so that's kind of plays into the bigger picture of this massive movement of sediment in the lake, sometimes within a relatively short period of time. And then we have to consider, you know, what is releasing that sediment so that it can be transported like that. Is that a natural phenomenon, or is that due to an anthropogenic increase in activity? And so, you know, we're kind of in really deep here. It's like a big can of worms of all these things we have to consider with inlet currents and everything. And so we're really focusing on how do we quantify what is happening on the shoreline and how is all of that stuff moving. So if you go to the next slide, really like why did we choose to use this technology and not you know, a pin erosion study or something, not just because of the accuracy, but you know, what might you gain from using this method? We had this equipment available to us, fortunately, from Dr. Jan Eitel through the university. So we were able to use it. And it is really accurate. That's awesome. There are other methods to measure erosion, but this is really up there as far as accuracy goes. And then this technology allows us to quantify sediment movement in the lake. So we can see where sediment is eroding and where it's accreting, and really understand at least most of the picture of sediment movement to and from the shoreline. There are a few drawbacks that I think it's important to mention. For one, it is pretty costly. It's not something like your average, you know, everyday independent person could afford. And it also requires a specialist or someone who knows what they're doing to start out with when it comes to, you know, scanning and processing and getting anything useful out of this. Or at the very least, you need a willing master's student, which is me. I got put up to that, so great. And if you could go next, please. So I mentioned that it was costly. I'm just going to break that down really quick. So the biggest cost is the scanner itself. The scanner that I use generally costs between $15,000 and $20,000 on average, and that includes some accessories, but not really any of the equipment or software necessary for actually processing or analyzing the scans. To do that, you require that Leica Cyclone license that I mentioned earlier. That can range anywhere between $900 and $6,000, and probably out of that range on either end too. There are educational discounts and other things like that, but that's kind of the general range depending on what kind of software you need and what you're going to use it for and how long you want your license to last. So to analyze the scans, at least this program that I use, you know, you get a freebie, which is great. And that's a big part of the reason why we chose it, is that it was free, because Cloud Compare is that open source software. The time aspect, as far as costs go, the time for a scan, like I said, runs about an hour, but that really varies. You could probably do the whole thing, set up and take down and scanning in 15 minutes, but you could, you know, you could also take probably 2 hours. And so there's, you know, there's other similar techniques. The analysis takes a little bit of time, depending on, you know, your network capabilities and everything like that. So just to summarize really quick, because I know my time is up, and you can click through the bullet points on the slide. This is basically, you know, this has its pros and cons. It's really accurate, but it can be expensive, but it's really cool for understanding your shoreline. And then we're going to go on and do more with this. We're going to characterize the shoreline and try to associate nutrient concentrations with this moving material. So I want to thank you all for watching. I want to thank the Big Pale Lake Water Quality Council for raising the funds for this. I want to thank WALPA for letting me present, and the University of Idaho and the McCall Field Campus, and Basile and Frank and Jan, who have all helped me. If you guys have any questions, because I know this is a lot, please feel free to reach out to me. I am available, or email questions now and we'll get to them later. So thank you very much.
Thank you, Heather. That was an awesome project and really looks like a useful tool. So next up, we have Sean Ahearn. He'll be talking about isotope tracers in nutrient source tracking. Welcome, Sean.
Hi, and thank you, everybody. My name is Sean Ahearn. I'll be guiding us through this talk this afternoon, isotope tracers and nutrient source tracking of nitrate, a different perspective on surface and groundwater remediation. I want to thank you all for joining me this afternoon. I know that the conference is almost over, so thank you for those of you who are still here with us. And a thank you to the WALPA and to Rob Sysette for this opportunity to share with you guys how isotopic analysis can improve water quality projects. My goals for this talk are going to be to define isotopic nutrient source tracking, review nitrate and boron, their origins, and how the analysis works to define pollution sources. And then I have a brief case study to review that should wrap it all up. So for those of you who aren't familiar with Beta Analytic, we are celebrating 40 years this year of radiocarbon dating. We also do stable isotopes, which is what I'll be discussing today. We do a lot of different sort of services to help people understand the physical world. We're also a proud certifying body for bio-based products. So you might have a water bottle or toothbrush that is a plant-based material that may have gone through our laboratory for certification, as well as to show off our ISO certification. So that is the International Organization on Standardization, and what that does is it proves our competency. We're regularly audited to prove our competency to measure these ratios in a reproducible manner. So for those of you who aren't familiar with Beta, this is what we've been up to for the last 40 years. Something that I like to kind of emphasize to people is that when we're talking about isotopic analysis, we're talking about how to understand the physical world in a different way. So Beta and Isobar are companies that we're one big company, but depending on the service, your report might come from Beta or from Isobar. But what we're doing is we're helping people understand the physical world. So this is a great paper by Matos and Jackson that sort of reviews the idea that from origins to diet to chemical reactions taking place, isotope ratio mass spectroscopy, or IRMS, or really, mass spec, can really help us in understanding the physical world around us, and also to prove that things are what they say they are, and that they've come from where they've come, and that products or even timelines are accurate. So for those of you who want to take a deeper dive into mass spec, I highly recommend checking out this paper by Matos and Jackson in forensic chemistry. If anyone's interested in learning more, just let me know, and I can always get you some more information. This is just a teaser slide. I wanted to go ahead and kind of let you know where we're going. At the end of the talk, we're going to be talking about this case study where the combination of nitrate and boron isotopes, as well as a microbiological indicator, were used to define the sources of nitrate in a karstic groundwater system. And what was really important about the study is that over several decades, the water quality had been continuously becoming more and more impaired, from 5 milligrams per liter nitrate to 25. So it came to the point where finally these researchers needed to define a source, and their approach was to use isotopic analysis, and we'll talk about why in just a few moments. So before we jump into looking at data, I just wanted to make sure that we were all familiar and on the same page as far as stable isotopes and what it is we're reviewing. So a stable isotope is a variation of the same element, but just with a different number of neutrons. Therefore, its identity and overall reactivity are the same, but you pretty much have one that's a bit more massive and therefore more sluggish during reactions and phase changes. What fractionation means is that because something like evaporation is taking place, you're fractionating the atom pool, right? And we have an example here on our right that shows that if a beaker of water was, on a hot plate and evaporating, we would expect that there would be a fractionation process or a separation where the 1H's would be more present in the vapor phase, whereas the 2H's would be more present in the liquid phase, right? So it's these changes that refer to fractionation, and that's what helps us develop the what's called the delta notation, right? So the delta notation here, what we're doing is we're suggesting that compared to a standard, these ratios of 1s to 2s, or whatever element you have of interest for that stable isotope, we compare that to a standard, and when it's positive, we call it enriched, and when it's negative, we refer to it as depleted. Now, what's really great about this kind of analysis is that these standards are actually both nationally and internationally generated and sold to labs all around the world, meaning that data sets from the states can be compared to data sets in Europe and in South America, and it really just allows us to have a lot of confidence in the kind of data we produce and know that our machines are running well as we run these standards through our machines. Right, so again, stable isotopes, same element, different variation. We're using the fact that these different forms of the elements that have different masses fractionate, and that fractionation can actually help us reveal processes that are taking place and the origin of substances. So I just wanted to remind everyone of why we track nutrients, and really it comes down to eutrophication. Eutrophication can greatly impact recreational waters, causing algal blooms and bringing all sorts of toxins to the water. These poisons can bioaccumulate, and they can even hit your dinner plate. But really, something to consider is marine and fisheries industries that are also relying on this clean water for the health of estuaries, bays, and large lakes. Something that I like to remind people is that even if you feel that the environment and balance in the environment is not the most important thing, well, then just consider the economy and realize that keeping nutrients in balance is also helping not only ensure that we are happy and healthy, but also ensuring that we have plenty of work and food to go around. One of the big challenges in tracking nutrients is differentiating between point source and non-point sources. So our point sources tend to be pretty well regulated outfalls. They can be sometimes high in nutrients and high in other chemicals, but for the most part they are regulated. Our real big issue, and something that this data helps elucidate, is non-point sources. That's stormwater runoff, septic tanks leaking, large agricultural areas that are all coalescing to one spot. So what ends up happening is all these sources mix together, and it can become difficult to understand which is the leading cause of pollution. And that's where isotopes can come in to really help and understand where pollution is coming from, what processes are these non-point sources going through, and how can we really target our remediation efforts. So nitrate, what is nitrate? Well, nitrate, it's a naturally occurring molecule that is essentially a vehicle for nitrogen within the nitrogen cycle. Right, here's a fun cartoon that kind of expresses, this is a very abridged nitrogen cycle that's focusing on nitrate, but what we can see here is that nitrogen fixing bacteria pull nitrogen out of the atmosphere. They now make that nitrogen as nitrate available to plants, animals, and the death and decay of plant matter then turns into organic matter. That organic matter is then mineralized and nitrified and then denitrified back to N2 gas. So pretty much what we have here is, an example that the nitrogen in a nitrate molecule is undergoing several different reactions from formation, death and decay, reformation, and then all the way back to disintegration. So what we can do is utilize all these reactions taking place to understand the origin of nitrate and the process being imposed on it. Here's a graph that sort of summarizes what we would expect the isotopic reactions to be. So we can see that nitrification, we actually expect things to shift in a negative manner, righty? And then when it comes to denitrification, we could see that we expect things to shift in a positive manner. And that would be a depletion versus an enrichment. What is very useful about tracking nitrate is that we're getting information from both a nitrogen and an oxygen molecule. And what that allows us to do is to get even more information on the processes that are being taken place to help us better understand the origin. And let's see what that looks like. So here on this biplot, what we could see is that we have our delta 15N of the nitrate and our delta 018 of the nitrate plotted. And already we can see some of these ranges of known substances. So the USGS has published these ranges. Carol Kendall et al. Has gone through a bunch of different N members or potential sources and defined some of these regions. So we can see that this green box here is from manure and sewage. We have inorganic fertilizers, nitrate fertilized, precipitation. This is actually very common in urban areas due to combustion reactions, as well as lightning strikes that generate nitrate. But ultimately what we can see here is by looking at the delta 15 and delta 018, we can already begin to suggest what sources are or are not present, and we can also see where they're mixing. Furthermore, what's really important is this trending here. So here we have labeled denitrification. So if we had our data populating along a line, with this trend, we could begin to speculate that there's some natural remediation taking place, maybe something we want to augment or improve, and then also nitrification, and that would be ammonia, fertilizers, and rain. So again, this data set begins to really bring together what's happening to this dissolved nitrate, where it's coming from, and where it's going. So far we've talked about nitrate, the fact that it's natural, and the fact that using these two isotopes can help us understand what's going on with that nitrate. But let's shift gears. So boron is interesting because, and I was really surprised to learn this when I was doing research, was how ubiquitous it is. Here are some estimates from 1972 about all the different processes where boron's present. We have glass formation in ceramics, mining, but soaps and cleansers really just outcompete it all. And what we tend to, not always realize is that our homes and our domestic waste coming from apartment buildings, septic tanks, and pretty much all of the stuff leaving our common household items are actually full of boron, which have very distinct and discrete values. What this allows us to do is to actually help us pinpoint these sources of pollution. What makes boron a very useful tool for isotopic source tracking is this large difference in their stable isotopic values. So we can see here, or I should say in their isotopes. So what we can see here is that the boron 10 is actually almost 20% of the stable isotope percentages, and the boron 11 is almost 80. And what this leads to is a very wide relationship between boron 10 and 11 that allows us to better understand the sources of all these different kinds of materials. So for example, coal here has a very wide range, but they're always negative. What we'll be interested today is in sewage and contamination. But we can also see that there are, seawater intrusion examples. Here, detergent, something else that's interesting. Manure, which we'll look at in a moment. But ultimately, we can begin to start to see that we have nitrate isotopic ratios that are helping first define some ranges, and then now we're using boron to go ahead and refine those further and better understand them. And I kind of alluded to this a second ago, but what we can do is combine the delta 15N and the boron 11, and we can begin to look at all these sources and use all three of these isotopes to understand the origin. And what really pops out, and what's probably the most important part of this graph, is that it helps to pull apart the manure and sewage signatures that can become very difficult to understand in non-point sources. When these two sources are mixing, there could be a lot of arguments as between what the major source is and what sort of policies to take. So by taking this kind of approach, we can actually get insight into the mechanisms being imposed on the contamination and better understand its source. Okay, great. So now we have some background on what stable isotopes are, what fractionation means, how we can use that fractionation to help us understand the sources and reactions being imposed on our contaminants. Now let's see this kind of information in action. As I had mentioned before, this is an area that was under a lot of agricultural land use, and since the 1970s till 2013, there had been progressive increases in contamination, and it came to a point where these researchers now needed to define a source. As I'm sure most of you are aware, in agricultural areas, due to large amounts of releases of nitrogen, there is a very high chance that fertilizer and manure could be contaminating the local groundwater table. However, sometimes it can become very difficult to determine that is the real source of the contamination, and this is also where it becomes difficult to decide what sort of best management practices to take. So during this research, and again, I'm sorry, I just wanted to add some color. The first approach taken was to measure the nitrate isotopes, and we can see here that we are able to show that, nitrate from the atmosphere and fertilizers are very likely not a culprit here, so we can basically rule out inorganic fertilizers. And now we're in a sewage manure area and with the potential for some soil and organic matter. We can also see here that there is a nice denitrification trend, suggesting that there is some natural remediation taking place, and researchers can use that to understand the rate and potentially augment that area as we talked about before. So from just this one data set, we already can begin to understand origins, and now with the boron, we can refine it. So now with the addition of the boron isotope, we're able to further refine these boxes and show that indeed the agricultural practices in the area are the leading reason for these increases in nitrate and pollution concentrations in this area. And now informed practices and decisions can be made to improve this water quality. Another point to bring up is that there were no markers for human waste with the bacterial source tracking, so just as a more confidence in our proxies. So why bring this up? Well, isotopic nutrient source tracking of nitrate and boron were able to confine contamination sources and improve remediation efforts in the area. Further, boron and nitrogen proxies are able to help researchers and stakeholders understand their current water quality issues to better tackle them. I want to just thank everybody again. We were able to define isotopic nutrient source tracking, review nitrate and boron origins and how they're used to define sources, and we reviewed a case study. So at this point, I just want to thank everybody. I'm sure I'll be unmuted for questions. And, again, thank you very much.
Thank you, Sean. That was very interesting. I know EPA is just funded $6 million plus projects looking at source tracking of nitrogen. So you're in the right field. Look forward to questions. And next, our last presentation of the day and of the conference is Rob Zizet, our current president. He's talking about monitoring phosphorus and fecal bacteria loading in Lake Whatcom.
For coming to the WALPA conference, and thanks for sticking around for the very last presentation. This presentation is a follow-up to one I gave to WALPA in 2017 when we first investigated the impacts of septic systems on water quality in Lake Whatcom. The question was asked to me by the Lake Whatcom Water and Sewer District. Are on-site sewer systems in the North Shore Basin impacting public and environmental health of Lake Whatcom? There are 100 septic systems in this North Shore Basin. They're located just across the lake from where the sewer district takes their water supply from, and as well as the city of Bellingham takes their water supply from, and they're concerned that the septage from those systems are getting into the lake. And in fact, due to that concern, they had proposed to extend the sewer from the city down along the 3 miles of shoreline where these septic systems are located to intercept them and connect them to the sewage system, which they also manage, by the way. But their attorney told them they're not allowed to do that because the Growth Management Act will not let them do that unless they can prove that those septic systems are in fact impacting public and environmental health. And at that time, using fecal bacteria as a measure of public health and phosphorus as a measure of environmental health, since there is a fecal and phosphorus TMDL on Lake Whatcom, and the entities are spending millions of dollars a year in managing stormwater to reduce phosphorus inputs to the lake, but not anything principally on the septic systems other than ongoing maintenance. Anyway, we did find that using human fecal biomarkers that OSS are getting to the lake from septic systems. We found high to moderate concentrations of fecal biomarkers in 6 of the 18 drainages that we sampled. And we also found, though, that they didn't correlate, those concentrations didn't correlate well with fecal bacteria. However, that's not unusual with DNA tracking studies because of different transport mechanisms between those parameters that we'll talk about later. So moving on to the 2020 question, well, that was fine, but you didn't take very many samples, and how do we know that the loadings, even though you calculated some not very accurately with a study that wasn't designed to calculate loadings. Let's redesign the study, calculate some loadings, and look at loadings from a sewered area that, in fact, to prove that sewers aren't contributing comparable amounts of fecal bacteria and phosphorus to the lake. So here we have our 3 study areas. The OSS areas on the north shore of Lake Whatcom, shown with the 100 or so orange dots representing septic systems and the 20 or so red dots representing drainage outfalls that were sampled. The new sewer area that we sampled is located across the lake in the area served by sewer shown in pink, located between the city of Bellingham intake on the northwest and the district's intake to the southeast. The undeveloped area is located beyond Smith Creek, southeast of the OSS area in Lake Whatcom Park, where there are no known human sewage or septic sources. The study design was to use 5 drainages, to sample 5 drainages in the OSS area. These are 5 drainages that we intentionally selected where we found human biomarkers before. So we did not randomly select them. They are actually targeting known previously contaminated areas. And 5 more, not randomly, but we picked 5 drainage basins in the Seward area that had very different size of flow and basin size and were readily accessible by foot. The first one we did in 2017 was all by boat. This time we did it by foot. And then we picked 2 drainages of different size in the undeveloped area. We sampled also 1 of 2 septic tanks in each of the 5 events, obviously located in the OSS area, and then a municipal sewer, shown here, sampled in the sewer area. 3 storm events, 2 basic flow events in the spring of 2020. Storm events were between a half to an inch in 24 hours. The field measurements really consisted only of flow measurements, so we could expedite things and just grab samples and measure flow. Take those samples back to the lab instead of doing optical brighteners in the field to track sources like we did the first time, as you may recall. We just tested whether this lab method of optical brighteners would work by using a UV light to degrade the optical brighteners, which does not degrade the natural background interference, positive interference we get, fluorescence from organic matter. So we tested that out, and along with conductivity. But really, we're looking at fecal coliform and E. coli and total phosphorus. We did look at 2 human biomarkers this time, as well as last time, but different ones. HF183 is one of the same biomarkers we used in 2017, but it's been renamed because it's been promulgated as an EPA-approved method since 2017. HF183, and then we added an experimental one that's just been developed by the University of University of Wisconsin researchers named it BAC V4 V5. They isolated it from municipal sewage and in fact determined that it's most prevalent, more prevalent than HF183 in the sewage, but most prevalent in the biofilm on the sewer pipes, that it's actually in Bacteroides, growing in the biofilm, not in Bacteroides present in the human waste itself. Here's just a map of the drainage basins that we delineated using Lidar to each of the 5 OSS drainage sampling outfalls, along with the 2 septic systems to the southeast, and further to the southeast, the 2 undeveloped sites. And across the lake are the 5 sewer area outfalls that we sampled of varied basin size, along with the sewage site draining the Strawberry Point neighborhood. The total phosphorus results are shown here in box plots with blue for the undeveloped, green for the OSS, and brown for the sewer sites. We found high phosphorus concentrations, over 50 micrograms per liter, in all but 2 of the OSS and 2 sewer stations. This threshold has been developed by Robin Matthews, who sampled for years tributaries to Lake Whatcom and used that threshold to identify where mean concentrations exceed that in developed tributaries and typically were less than that in undeveloped basins in the watershed. We found even much higher concentrations, over 300 micrograms per liter at one OSS station, and that's 520. Important to note that, as well as we did go upstream of station 440, even though the mean was less than 100. We did find concentrations over 300 in an upstream station in 440 that's not shown in this graph. One interesting observation, however, was that phosphorus concentrations were in fact lower during during higher flow. So as the concentration As the flow increased, phosphorus concentration decreased from base to storm flow, as well as comparing the 2017, where we sampled extremely high flow rates during very large storm events over an inch or two. We saw that same pattern. And it's theorized that, in fact, which we've seen elsewhere, that in forested watersheds, which all of these really are principally, the groundwater phosphorus concentrations are higher in base flow and actually get diluted by forest runoff. Anyway, concluding, also these high phosphorus concentrations were observed in septic tanks, even higher than the sanitary sewer, but both of which are similar to the literature value of 10,000 micrograms per liter, commonly reported. Now the fecal bacteria results are shown here for E. coli on the right. We did not find high concentrations over our threshold of 500 on average for a geometric mean, shown in red X's, by the way. But we did find moderate concentrations at station 440 in the OSS area, as well as a sewer station 485 in the sewer area. Fecal bacteria concentration did follow a pattern of being lower at lower flows or increasing with flow, likely due to runoff containing animal deposits of feces in these basins. E. coli was higher in sanitary sewage than the septic tanks, presumably due to the settling of solids in the septic tanks versus the suspension of those solids in the sanitary sewage. Now the fun stuff, the biomarker results. We have the BAC V4, V5 up top and HF183 down below. The threshold of 2,500 we developed is about 10 times the quantitation limit for this qPCR method. And we found actually higher concentrations of BAC V4, V5 than HF183 in all sites. And we found high concentrations of BAC V4, V5 at 3 of the 5 OSS stations shown in the upper graph, 520, 430, and 440. We also did find a high HF183 at 520, but not at those other 2 OSI sites. So we interestingly found higher, not shown here though, but in the sewage samples we found higher BAC V4, V5, as well as the septic samples. So this is a much better human marker for this watershed for both sewage and septage because of the higher concentrations and the better sensitivity. We'll note down below HF183 was found at moderately or low, moderate levels at undeveloped basin 1, the very first blue bar, with a median concentration of 1,000, and also lower concentrations at site 516 or site 516. But anyway, those lower concentrations of 183 were much lower than what we observed at those 3 high OSS sites. Continuing on with the biomarker results, the patterns we saw among the 5 OSS stations in 2020 matched those we saw in 2017, with 520 being the highest on down to 466 in that order, as well as the levels of concentrations themselves. Secondly, the important finding is again, which we had assumed or concluded in 2017, but that because we're not seeing high fecal or high phosphorus concentrations in these drainages with high human biomarkers, that transport mechanism is through the soil, not overland flow, not failures that weren't observed by the health department either, by the way, and that human biomarkers are transported slowly through soils, but more readily than fecal bacteria, which die off by those slow transport rates, and phosphorus, which is absorbed 2 particles along its pathway to the water. Loading analysis pretty much showed the same thing as the concentration. When we look at aerial loadings on an annual basis, those 3 OSS stations, 430, 440, 520, were much higher than any of the undeveloped or sewer stations. But when we average them over each of the 3 areas, over the year, we found that, in fact, the sewer area had the highest phosphorus loading rate of 0.19 compared to 0.08 for the OSS and the undeveloped areas, clearly showing that septic systems are not a significant source of phosphorus loading to Lake Whatcom. This conclusion actually agrees with what we concluded in 2017 in our crude estimates of loading, showing it or estimating it to be less than 10% of the total load from the septic system based on a difference in concentration, as well as by other researchers in 2011 using literature values for septic system loading rates, predicting they would amount to less than 15% of the total TMDL load attributed to the North Shore Basin. And finally, we did assess whether the 68 of the 100 systems were inspected by the Whatcom Health Department between the 2017 and 2020 study. They weren't able to get access to the other 32, and of those 68, 5 were found to have either a need of repair or maintenance. 2 of them landed in 2 of the basins we studied, 466 and 430, and we found no appreciable decrease in human biomarker input between the time that those repairs were made. However, further investigation would be needed to determine if other contaminants in septage may be getting to the lake other than phosphorus and fecal bacteria. In conclusion, nope, OSS are not a significant source of fecal bacteria and loading to the lake because septage is transported slowly through the soils and fecal bacteria die off in those soils, phosphorus is absorbed in those soils, as has been reported by others, but we don't know what's happening with these other chemicals. And that, in fact, septic repairs by the health department did not appear to reduce the low amount of septage inputs that were observed in 2017. We do recommend, however, following up with some source tracking in 2 basins that showed high phosphorus and high human biomarkers to see if those sources could be controlled in basins 440 and 520. And with that, I will take any questions. Thank you.
Thank you, Rob. That was very interesting. Looked like a big project. Interesting that the results were the same from 2017 to 2020. So if anybody has any questions, please submit them to info@walpa.org. You can also use that website for any feedback on the conference and any questions you might have for any of the presenters that you weren't able to get to. And before we take questions, I just wanted to thank a number of people. First off, all the participants who are still logged on and logged on yesterday. I think this was a really good conference online. Secondly, I'd like to thank Rob Zizet in particular, along with Sally Abella, and call out Jennifer Oden, for their lots and lots of work that they did to make this conference work on the program and getting abstracts in. Really did a good job. Thank you. Like to present thank you all of the presenters. Everything was interesting. I learned a lot. I think the panel discussion yesterday on equity and justice was very important for WALPA, as was a discussion and panel discussion this morning on access. I think as we go forward, these topics will be incorporated into WALPA's work. We'd like to thank the sponsors, call out all of our sponsors for the conference. And again, call out UW-Tacoma for their great job that allowed us to have this online conference. And we appreciate your efforts and work very much. And as a personal thank you, I'd like to thank Jennifer Parsons for forwarding the questions to me and sorting through those. So as we get going on questions right now. So we have a question for Basile. when you looked at the macrophyte aspect, was there any distinction in the ability to prevent resuspension between submerged rooted plants like pondweeds or elodea that are further out versus those that are more shoreline only, like rushes and cattails?
Can you repeat the question, please?
Yeah, it's a long one. When you looked at the macrophytes, did you notice any distinction in preventing resuspension by submerged rooted plants that were further out versus those that are closer to the shoreline? Did either of those work better for preventing resuspension?
Rooted? What is?
Well, deeper plants, ones that are deeper in the water versus the shallow ones. Did either work better?
Oh, it wasn't mentioned in the literature. What was but between the big distinction was between flex one and between very erect ones, and about the strongness, the solid of the plant, if it was very strong or flexible, and it plays a great role on hydrodynamics. But yes, an emergent compared to the ones that was more deeper down, play a greater role more for breaking orbital movement and also surface movement than ones that was more deeper and coverage of the bed.
We had another question for you. And did you actually work at Lake Taihu in China?
Oh, no.
Let's see. The rest of that question was disappeared. Oh, so in Lake Tahoe, did you happen to notice if they tried to plant macrophytes to work on that?
One of the big problems that it was already too much eutrophic, and that the establishment of macrophyte was very difficult. But they tried some other strategy by making big wave breaking barriers of few kilometers that act on resuspension, and after, when they limitate hydrodynamic disturbance and all this suspended particulate matter to go in the water column, they tried to reestablish after the macrophyte in the same time as maintaining this barrier, but there is still not an article on the reestablishment of this macrophyte. But one of the big conclusions is that Lake Taihu, it's too late for reestablish macrophyte, and it's already too much eutrophic state.
It's famous or infamous for its toxic algal blooms, for sure. So we have a question for Heather. And Heather, what's the range of the laser on the Lidar unit? How much shoreline can you map from one location?
So, so that really depends on where you are scanning from. I've been trying to scan from people's fixed docks or piers so that I can get a little bit off of the shoreline, and that gives me a bigger range. But you can generally, it can pick up objects up to 200 meters away. It's more accurate as you get closer, obviously. And so I've been trying to keep everything kind of within a I don't know, 25 to 50 meter range, depending on my sites, and how the shoreline is, and you know how curved it is and how far off of the shoreline I'm able to get. So how big of a picture am I able to get of the shoreline? And then you can do a full 360-degree scan with that. And so so it can pick up objects that are, you know, a ways away, and you kind of get that whole circle of it, I guess. Does that make sense?
Yeah.
It's kind of complicated.
and also how deep? How deep? You probably mentioned that. But...
into the water, I assume. Okay, yeah. So it depends, like I said, it's really dependent on the characteristics of your water. I think it can go up to about 2 meters deep. And that, but it really depends on how turbid is your water and how how much does it move? What is the lighting like? So what's the reflectance of water? Things like that can really mess with the accuracy of scanning underwater. It does pick up things obviously really quickly. It scans, you know, through those points, you know, 50,000 times a second. But if things are kind of moving around, or you get a weird reflectance and that laser beam hits the water and bounces back off rather than scanning through the water because of a reflectance and a lighting issue, then you wouldn't quite get that. So we've been looking a little bit at maybe trying to see how accurate that is. With me going into analyzing my scans, but it can go up to 2 meters if you have like nice, calm, clear water.
That's neat, but it won't be replacing sonar for looking at bottom.
No, definitely not like anything. Yeah, not anything deep. We've just been using it for that near shore.
Another question for you. Do residents that live on the shoreline have complaints or concerns due to accretion? Would someone complain about increase in property regardless of natural or anthropogenic activities that cause these accretions?
Some people might, and you know, kind of like I said, most people that I've gotten calls and complaints from have been complaining about erosion because that upsets them. But I have had like that call with the example of the rock. I don't know if that man was really upset about the accretion necessarily. But he had really noticed it and he was kind of just like, this is crazy, like what has happened. And I have another site that I have, they have mentioned also like, oh, we've actually been gaining a little bit of beach is what they said. You know, it looks like the sand is higher up on the steps that go down kind of thing. The reaction that I've gotten from most property owners around the lake is not that they're as upset about accretion as they are about erosion, but that might change depending on if they knew like a nutrient effect that goes along with that, and if you have more sediment moving into your area, into your beach, if that's bringing in more nutrients, and then you could potentially have more growth. And most people really don't like having macrophytes in their beach or off of their dock. It scares them. So that really depends on the person, but generally it's a lot more negative of a reaction to erosion than it is to accretion.
That's interesting. So we have a couple questions for Sean. Can isotope tracers be used to distinguish nutrients resulting from internal loading?
That's a great question. And for that kind of question, what I would suggest is if we were to measure the bed load and then compare that to the suspended load, we can actually assign an isotopic fingerprint. And also there has been research done in Lake Superior that actually showed lake bed sediments producing more nitrate than there were inputs. So the short answer is yes, but I would also consider some strategy to it. Since we do have the ability to fingerprint a particular source, we can fingerprint it and then identify it. So yeah.
So another question for you. Have you done many projects in Washington or Idaho?
So unfortunately, we have not made it to the Northwest, but we have done projects in the West. I'm in Miami, Florida now, and we've actually done the bulk of our work so far on the East Coast. So this is a really great opportunity, and thank you guys again at WALPA for letting me be able to like talk about this kind of stuff.
Oh, very interesting. Yes. Okay, and then we have a question for Rob. What do you think the key elements you would carry forward to a new lake system to understand the impact of OSS on septic contributions to the lake?
Well, I think the human biomarkers is a great tool. I think estimating nutrient load from septic systems is a challenge that we've been up against for for decades. It takes a lot of effort to monitor phosphorus transport in the subsurface. But I think the biomarkers are great for identifying problem areas and looking to target those areas in more in-depth investigation to see if you can control those sources without being too hung up on the quantification aspect of the biomarker and how it doesn't necessarily reflect the loading from phosphorus, for example.
Okay, so we have a general question. Is there access to the presentations after the conference? Do you have the website on how we can access and listen to these presentations?
Yes, it's a good question. Everybody's asking. Yes, there will be access to all of them. University Washington Tacoma will be posting them for 2 weeks. We'll post that on our WALPA website, what that link is to get those. And then WALPA has plans to post them beyond that. We haven't quite figured out how and where that's going to be, but that's the plan, is they would be available even beyond 2 weeks. So look, we'll get that information from them and we'll put it up on our website. Yeah.
Okay, I've been reminded to say that we still have time to donate to WALPA on our website. And thank you to everyone who's donated extra. That will help next year in our scholarships, since we didn't have an auction this year that I could buy everything from. And anyway, I think that's it for questions. If no one has anything else, we hope to see you next year in October in the Tri-Cities at an in-person conference if we can. And if not, we're going to talk to Rob again and he can set up a whole nother conference next year. Thank you, Rob. And thank you, everyone.